Hello everybody, welcome back to another episode of Coding with Culp. It's been a while since I've made any videos. First of all, before we begin, I would really appreciate it if you took a moment and hit the subscribe button and the like button down below. It would really help me out. So the channel's been gone throughout the summer and a little bit of the spring. Essentially what happened, my little workshop up here, it's the smallest room in the house. I got it packed full of stuff. And my wife ended up having to work from home, so she worked out of the workshop for most of the summer. And anyways, I'm now able to make videos again. I've got a lot of them in the pipeline, a lot of retro computing videos, which is what this one's about, and a lot of coding videos. So let's get started with what we're doing today. So I love retro computing, love retro computers. I grew up in the late 1970s and the 80s, and my very first computer was a Texas Instruments TI-99 4A and then a Commodore 64. And I love computers of that era. And so really what I like, my retro computing interest, are really kind of combining the past with the present. That's kind of what this does right here. So what this is, it's the RC2014. It's a basically a kit computer that you build yourself. It's based on the Z80 microprocessor, and it's really kind of a homage to microcomputers of the 1970s and the early 1980s. And so I ordered it from Tindy, and I'll put a link down below to from where I ordered it from. And I'm here in the United States, and it took just a few days to get from Great Britain to Chicago. And then it sat in the Chicago processing center for something like a month, or close to it, maybe three and a half weeks. And it finally got to me. I was thinking it was going to sit in that Chicago processing center forever. But let's take a look at what we have on the inside. So like I said, it's a kit computer. You're going to build this yourself. And essentially what you have is a backplane. I'll show you in just a second. And you build cards, add-on cards, and those cards plug into the backplane. And you can customize and configure your RC2014 with the abilities or what you want it to do by building different types of cards. So let's see, we got a couple stickers right here. I'm gonna fish from the bottom up because I know what's on the bottom. Let's see here. All right, so this right here is the back plane, and what you'll have is headers, female headers on here, and you'll build cards that essentially slide in or slot into those headers. For example, you'll have the CPU card, which just runs a Z80 micro processor. You can have serial input and output card, video card, graphics card, that sort of stuff. So that's the backplane. Now let's take a look. I bought the RC2014 Pro Kit, by the way, and the Pro Kit comes with a few standard cards to get you going. Let's see here. I think, let me look through here. Yeah, this is the package of standard cards that it comes with. And let's go ahead and open it up. Maybe. There we go. All right. So we've got a CF card. And by the way, everything on this kit is through hole soldering, so you don't have to worry about any surface mount. The only surface mount thing is the CF card adapter, and it's already soldered on for you. So this is the compact flash storage card. Let's see, what do we got right here? This is the Pageable ROM card. $64K of RAM. I know that doesn't sound like a whole lot to a lot of you. But back in the day, back in the late 70s and early 1980s, 64 kilobytes of RAM was huge. I mean, absolutely enormous. I think my first computer, the Texas Instruments TI-99 4A, got it about, I think, 1981. I believe that thing has 48 kilobytes of RAM. One computer had the Timex Sinclair ZX81, had 4 kilobytes of RAM on it. 4. All right. I believe this is the dual clock reset card. dual serial card. So what you'll do to connect to this is it doesn't have any built-in video. You can get a video card for it, but it doesn't have any built-in video. What you'll do is you'll connect, I think it's down here, there's a serial, yeah, serial dongle, and you'll connect to it via either a serial terminal, if you've got one, which I do, or you'll connect it to your PC and fire up a serial emulator, or terminal emulator, excuse me, and communicate with it via that. And this right here is the Z80 CPU. The Z80 CPU was used on quite a few things back in the 70s and 80s, the most famous of which was the Sinclair ZX Spectrum, which we didn't have here in the United States. It was huge. It was all the rage over in Great Britain, but they really didn't make it over here to the United States. They did it in a couple of different ways, the Timex Sinclair ZX81 and the Timex Sinclair 2068, which I've got both of those here. So those are all the cards that come standard. Okay, those are the standard cards. And I bought quite a few add-on cards. And there's a ton of add-on cards. I mean, just an enormous amount. This right here is the 8266 Wi-Fi adapter, so you can actually connect this computer to Wi-Fi and use it to communicate with other computers. Text-based, of course. But I'm really excited to get it going and dialing into some text-based BBSs, which stands for Bulletin Board System, if you don't know. I think this is the digital I/O. So this has 8 digital inputs and 8 digital outputs on it. And let's see what else we got here. 2 more cards. I'll do that one last. All right, this is a 512K RAM and 512K ROM module. And you're able to run CP/M with this. CP/M was a operating system that predated DOS. And it was the most popular operating system for microcomputers in the 1970s and into the early 1980s. And then right here is the Raspberry Pi Zero terminal module. So I was telling you, it doesn't have any video out. And even with this, it doesn't have graphical video out. But what you can do with this is you use a Raspberry Pi Zero, not a 0W. It's got to be a 0 if I'm not mistaken. And you can connect it to video and connect a keyboard, and then you can use this standalone. Okay, you power it, plug it into a monitor, and plug in a keyboard, and you're good to go. All right, so those are the add-on cards that I bought. Let's see what else comes in the kit. These are all the headers you're going to need, both male and female. All the ICs that you're going to need. More ICs. So 2 bags of ICs. All the tons of capacitors and a bunch of sockets. This is a power cord, so that'll go into your standard 5-volt style wall wart used for cell phones and charging, that sort of stuff, and then that goes into the power adapter of the backplane. Looks like we got some rubber feet, a whole bunch of resistors, a couple capacitors there, and so right there is the power port. We got some LEDs and a few little parts, such as the power switch, a couple electrolytic capacitors, some jumpers, etc. And then this is the compact flash, which has everything you need on it. All right. Like I said, I'm going to build it. I don't know if I'm going to build it on camera. We'll just see. But I'm going to start with the backplane. And I'm going to start with the CPU board and go from there. So let's break out the soldering iron and let's get going. Let's build this thing. All right, I've got all of my parts sorted, and so I'm going to begin building the backplane. I'm actually going to start with all the power stuff up along this top row right here. Take that out. So we've got our reset switch, 2.2K resistor here, a 330 ohm resistor here. There's a few other parts that I'll get to. Power switch right here. the 5-volt power. This comes in from the 5-volt wall wart. I'll put in the power LED, which goes right here, and make sure you got your polarity right. The long end is positive on your LED, and I'll do that in just a minute. And then right here we've got a screw terminal, which goes right here. These parts right here are unpopulated. That's for a 7805 voltage regulator. And 10 microfarad, 100 microfarad electrolytic capacitors go right there. Those are unpopulated. You do have to put a link or a jumper between the 5-volt direct right here. So I'm going to solder a little 2-pin header right there, and then there will be a jumper placed over it. So let's get to work. All right, I got all the top row power stuff soldered in place. So we've got the reset switch, we have the 2 resistors in place, we've got the screw terminals in case you want to power it off something else besides the power jack right here. In addition, soldered in the jumper over the 5-volt direct. It actually comes with a right angle jumper. I put in a straight jumper. Hopefully that's not gonna not gonna ruin anything. I guess we'll find out. It shouldn't, unless it gets in the way of something else. And I got the power switch, and at this point we can actually plug in. Make sure we're off here. All right, let's plug in, and there we go. Green LED is lit. Okay, I'm going to go ahead and solder the rest of this together. I'm going to put in the female headers, all of the capacitors, and all the other components, and I'll be back when it's done. I wasn't able to show me, soldering live because, well, my eyes are pretty bad at 52 years of age. I got to wear progressive trifocals, and I have to get really in close in order to solder. And you don't want to see the top of my bald head bent over a bench soldering. So I'll be back when it's all done. All right, I'm still soldering the backplane together, but I wanted to give you a little tip. As you're soldering these really long female headers in place, what I like to do is I like to solder in just the end, 1 pin on the end, make sure it's straight, and then solder in the other pin on the end before you solder in anything else. And that way, if it's not straight or it's not flush up against the board, you can just apply a little bit of heat and straighten it out. And that way you don't go along and solder every single pin, and then you turn it over and realize that it's not flush to the board, or it's tilted and not straight. So it's just something to be aware of as you solder these in place. Another thing, on this one, you actually have a row right here and another row right here, and you don't actually solder any connectors in here. On the other side of the board, you can see those 2 rows have links. Okay, there's little links in there, and what that allows you to do is you can actually cut those links so that you can isolate these slots and these slots over here. All right, I'm going to go back to soldering this thing, and if I run into anything else, I will let you know. Okay, I have finished soldering together the backplane, and wow, did that take quite a bit of time. I don't know exactly how many solder joints there are in this thing, but it's got to be, just rough estimation, well over 600. Including the fact that each one of these rows is 40 pins, and you've got 12 of them, so that's 480 right there. And then on the enhanced bus headers, these are 20s, there's 12, so yeah, it's a whole lot of solder joints. This is not going to be a one evening project. Couple of things. When you go to solder the enhanced bus headers in place, note that they don't start at the very end. And in fact, the board is marked. You can't see it on here, but it's marked where they go. But basically, you start at the top hole and drop them down, you'll be in the right spot. In addition, you're going to notice on mine, I've got a spot, or I've got an enhanced bus header on every single one of the slots. The kit only comes with, I think, 6 of these 20 by 1 female headers. I just happen to have some, so I went ahead and put one in every single slot, just so that I would have enhanced bus access on every single slot. The picture, if you go on the website, with the 6, just shows I think the middle 6. 1, 2, 3, 4, 5, and 6, I think, with the enhanced bus headers. You don't actually have to put them on right away. You can wait and see which cards you have that are enhanced bus, and because not every card has double row pins like this. When you are putting these in place, what I did was I took a single couple of these header pins like this, and I stuck them in place like this. One there, and bobbling this all over the place. All right. Just like this. Then I turned the board over, and once again, I tacked it in place, right there and right there. Made sure it was straight before I soldered the rest. And so I tacked them in place, made sure they're straight, pulled these out, and I did that on every one of those. Then once they were all tacked in place, I turned it over and soldered it all. I think that's about the only other gotcha. One thing you can do, if you want to check and make sure all your solder joints are good, each one of these bus points connects to the other one. Okay, so pin 1 is connected all the way across. So what I did, just to check, is I took a piece of header, this 40 pin header, stuck it in here, and then on the other side I did exactly the same thing. Then I put my meter in continuity mode, and I just went down pin by pin, checking to make sure I had continuity from this side all the way to this side. If you didn't have continuity, that means you've got something wrong somewhere in between those pins. Either you've forgotten to solder a pin, or you've got a bad solder joint. And so I did that. Another thing you can do, you'll see that if you look on here, these are 5 volts and ground. I just went along, applied power, made sure I was getting 5 volts and ground at each one of those points. So that's it for the backplane. Now we're going to go and we're going to move to the Z80 CPU card. So let me get that together. And once again, I'm not going to show live soldering simply because, as I said, I got really bad eyes. I got to get super close to solder. And like I said, you don't want to see the top of my bald head as I solder. So I'll be back in just a bit after I get the CPU card soldered together. Oh, one other thing before I go on to the CPU card is you'll be left, if you're new to soldering, you're going to be left with a whole lot of flux. You're going to want to take a toothbrush or something and dip it in some alcohol and scrub that and clean it off. Or a Q-tip works pretty well too. So make sure you clean that off before you go on. All right, as you are assembling your RC2014, I wanted to show you something on this CPU board. The CPU board does actually use the enhanced bus. You'll notice it's got double rows here and then a single row right down here at the end. You would think that what you would do is you'd put some single row headers, well, not those headers, but anyways, single row right angle headers here and then some double row headers here. But if you do it that way, it doesn't actually, the pins won't line up properly. So what you're going to do, okay, to make this easy, is you're going to take the top row of short pins and place it in here along the bottom row, so that what you've got, there we go. All right, so what you've got is that top row of the short pins is right there on the bottom row of the card. And here's the other row, the bottom row of the short pins. Then when you turn this over, you've got your long pins facing this way. What you're going to do, and I'm not going to do it on this one because I've already made one, you're going to take, and you're going to start with a pair of needle nose pliers, pulling out pins. You're going to count 16, okay? And when you're done with that, when you've got all 16 done, you're going to end up with something looks like this. And then it'll fit right in there, and you're going to have one pin left over at the end right here. So there we go. And you can just take and cut that off. There we go. And there, fits perfectly. And then it will fit, after soldering of course, right into your back plane. And you can see it's marked pin 1. So pin 1 will go in there, it'll all snap in place. And just note, because this confused me, you'll actually have an empty socket, empty pin right here at the end. All right, let me finish soldering up this, and I'll show you what it looks like when it's done. All right, here we are. We're gonna try to boot this thing for the first time. It's always scary at a project like this when you're testing it for the first time. And you know, you get that feeling of expectation and you want it to work, and if it doesn't work, there's a little bit of frustration there. But overall, I don't think I can't think of any reason why it wouldn't work the first time. I have double, triple, quadruple checked just about everything. Every single solder joint I've went over. I even went over it with a magnifying lens, just to make certain. I was incredibly careful, and I've double and triple checked every single component as I soldered it on. The only mistake I made while I was soldering this thing together was one of the sockets I put in backwards. There's a little notch on the socket that you're supposed to align with the little notch on the silk screen, so that tells you which direction. There's usually a little notch or a dot on your integrated circuits, your ICs, your chips, that tells you which way it goes. It's not going to affect anything at all. The notch is just there so you know which way to align everything, but I did put the chips in properly. You'll notice I replaced, if you can see it, I replaced the blue jumpers with red just because they're a bit easier to see. As far as grading this project, you know, is it a beginner project, intermediate, expert? It's a little difficult to grade. The whole thing isn't difficult. Nothing on this project is hard to do. It's all just straight soldering. In fact, there's only a couple of components that you really have to be careful when you're soldering to make sure you get their polarity right. You got a couple of polarized capacitors, a diode, and then a couple of LEDs. So all in all, it's not a hard project. You just got to be careful. I'd probably put it, just because of the sheer number of solder joints, I don't know how many there are, but it's got to rank up there, 2,000. I have no idea. If you're a beginner, you might not want to tackle it, although once again, it's really not that hard. It's just a lot of work, a lot of solder joints. All right, so let's get this thing plugged in. I've got all my cards in place. I have set all of my jumpers, which, speaking of jumpers, there's a nice little rundown of the jumper settings for the 4 major operating systems that it comes with. You got Microsoft 32K Basic, which is what I've got right here. I'll put a link to these down below. If I forget the link, just let me know and I'll stick it up there for both people that are going to watch this video. If I forget it, just let me know. Anyways, you got 32K basic, you got 56K Microsoft basic, SCM, which is small computer monitor, and CPM. And CPM requires the CF card. So let's get started and getting connected to this thing. I'm going to connect my FTDI. I just tipped my microphone. The FTDI cable. And it's going to go into port A. And you're going to want to make sure that your black wire, your ground wire is up top. So there we go. All right. You're going to want to make sure you plug it in. All right, got it plugged in, not turned on yet. What I'm going to do is I'm going to fire up a program called Putty on Windows. It's just a terminal emulator. All right, so what we're going to do on Putty is we're going to select serial. And we got to select the correct COM port and speed. So to find out the correct COM port, all we're going to do is we're going to go to Device Manager right here. So here's Device Manager, and we're going to come down here to Ports, COM and LPT, and right there it is, that USB serial port. That's COM6 for me. It's going to be different for you most likely. All right, so I'm going to select serial. I'm going to select COM6 just like this, and we're going to want to change the speed to 115,200. The default jumper settings on the SiO2 card puts it at 115,200 baud. All right, so we're going to click Open. That opens our serial port. Let's bring this over here. Let's make the text a little bit bigger. Change settings, appearance. All right, let's go up to, I don't know, 22-point font. That'll make it nice and big. All right, there we go. Okay, so now what I'm going to do is I'm going to switch it on. So hitting the power button, and we got power, and we got nothing on here. So that's a little bit worrying. Nothing has occurred, but oftentimes what you have to do on these things, hit reset. So I'm going to hit the reset button, and let's see what happens. Aha, there we go. Z80 SVC by Grant Cyril. For memory top, we're just going to press enter, and that should give us the maximum memory. And there it is, 32,382 bytes free, 32K basic. Copyright 1978 by Microsoft. I don't know how many people realize that Microsoft actually got their start making BASIC for these old microcomputers of the 1970s and the 1980s before they got into the PC market and business. And one of their first products was a BASIC for the Altair 8800. It was interesting. Bill Gates had programmed it. Bill Gates and Paul Allen had programmed it on, I believe, a PDP simulator. They didn't have an actual Altair 8800, and so they programmed it, I believe, if I'm not mistaken, on a PDP emulator, basically, or simulator that simulated the Intel microprocessor. And they didn't even know if it was going to work. And they flew out to New Mexico to MITS, which was the company that produced the Altair, and they weren't even sure it was going to work, and they loaded it up, and it did. Anyways, let's write a quick program. So 10 print. Sometimes I really have to admit I miss the immediacy and the simplicity of these old microcomputers. You turned them on, and bam, you were already in your development environment like this, and they had BASIC built in. So let's run it. There we go, hello world. Let's get a little bit more complicated real quick. Let's do the loop 5 for x equals 0 to, 0 to 10. And then we'll need 20, next x. So let's list it. All right. Oh, let's do something a little bit neater. Let's do 10, print, tab, x. Whoa, okay. You gotta press the shift key when you're doing the delete, by the way. At least on Putty. And then semicolon, if I remember my BASIC, will print everything on the same line. In other words, it won't automatically do a carriage return. Okay, what's going on? Okay, that's weird. Let me list something here. Okay, I messed up. 10 print, X. Why is it printing? Oh, duh. Oh my gosh. Okay, I guarantee it's going to work this time. Provided my fat fingers. See, it's weird because it won't actually execute the for loop until I press space. That's bizarre. So I don't know if that's a behavior of this version of BASIC or what. But anyways, it's all working. So we got a little cascaded hello world there. 32K BASIC appears to work. Let's do 56K BASIC real quick. So what I'm going to do, I'm going to switch it off. And now what I need to do, I need to come over here to my jumper settings. This little jumper settings document, and we need to set them for 56K BASIC. So the first thing I'm going to do is I'm going to pull out my RAM card. Actually, I wonder if I can do this. Let me see. No, I can't. I can pull it out. I was going to try and do it while I'm still in the backplane, but I need to pull it out. Alright, so let's reset the jumper settings. Take off my glasses here. When you get old, sometimes you get my close-in eyesight is actually really good, but my distance eyesight is terrible. Okay, so I have reset those jumpers for the 64K RAM card. You know, with these backplanes and everything, or the backplanes and the removable cards, this really is kind of a conglomeration or a mashup of old microcomputers in the 1980s, where you just turned them on and bam. You know, they went, and some of the first computers like the Altair 8800, where you had a backplane and switchable cards, and you configured the computer in a lot of different ways based upon those cards. And the old Altair, you had to build yourself. I'm not old enough to remember the Altair. I got into microcomputers 1979, 1980-ish, I think. My first one was a computer called the Texas Instruments TI-99-4A. Alright. Get this back in there. I think we're ready to go. I've got everything in there. So let's give it a try again. I'm going to turn it on. Let's come back over here to Putty. Now what I'm going to do, up here in the title bar, and hit right, and I'm going to reset the terminal. Alright, let's hit reset on the RC2014, and we get nothing. Alright. I probably have a jumper setting wrong, so let me just check it out. So when something does go wrong, and just make sure double and triple check everything. So I got that jumper setting right. Those are right. So let me just... May also be that I don't have it seated right in the... Okay, there we go. Alright, let's try it again. Once again, let's hit reset terminal. Ooh, we get nothing. We got something interesting going on here. It's bizarre that 56 or 32K BASIC would work, but not 56K BASIC. What I'm going to do though is I'm going to restart. I'm going to say... Let's try reset terminal one more time. Okay. Oh, you know what I could also do? Let me check my 64K RAM card. Make sure it's seated in there properly. Aha! I think that might have been the problem. Alright, let's start up Putty again. Alright, serial. 6. 115,200. Click open. Yeah, there we go. Once again, let me change the font here, make it a little bit bigger. 22 be good. Okay, so what happened was it was actually my 64K RAM card. When I put it back in the backplane, I didn't have it seated properly. Okay, so there we go. We got 56,958 bytes free. So the same thing. Let's write a quick program. 10 for x equals 0 to 10. 20. Let's get this right this time. Print tab x semicolon hello world. 30 next x. And let's do this. For x equals 10 to 0 step minus 1. Whoa. 50. And then 60 should be next x again. All right, let's see if it does that same behavior. Yeah, for whatever reason, it pauses at the for loop. I got to do a little keyboard input. And then, let's do this. Yeah, it's strange. Oh well. So 56K basic is working. One thing to note, you can't save your program. So I can't actually, save whatever I work with, and I can't get programs, say, off the internet and transfer them over to this version of BASIC. We can in CPM, and that's what we're going to boot next. So let's get this card configured, system configured for CPM, and let's boot CPM. All right. Here are the jumper settings for CPM, so let's get everything set up. All right, here I am back. I don't know if it's hours later, but quite a bit later. I had to stop the previous video because I couldn't get CPM to boot. It was giving me a huge amount of problems. Essentially what would happen is I set the jumper settings on both my Pageable ROM card and on the 64K RAM card. And it's supposed to boot a CPM bootloader, which it did. And then from there you load CPM up the CF card, and it was resetting. It would go back to that bootloader. I'd get an instant light of less than a second on the CF card, and then it'd drop me back. And I double, triple checked everything. Once again, went over every solder joint, checked the cards. I checked to make sure every single IC was the proper IC. It was oriented properly. I remeasured every single resistor, everything, and I could not figure it out. I was getting a bit frustrated. Turned out to be a bad CF card that I got with my CF kit. So what I did was I simply rewrote it, and what clued me in that was probably a bad CF card is that everything else was working. I could boot into 56K basic, 32K basic. I could boot into SCM, and the CPM bootloader, I could boot into that too. It was just whenever it went to access that CF card, it would quit and drop me back to the top of the bootloader. So, and also I stuck that CF card into a CF card reader. You're not going to be able to read it in a Windows machine, which I suspected and I verified, but it wouldn't even come up as a drive. It should be able to see that there's something there. It just can't read it. And so what I did was I used Win32 Disk Imager. It's a piece of software to write images onto different media. And I found images on the internet. Once again, for both of you that are going to watch this video, I will stick a link down below to those images. And so now I've got it working. So let's go ahead and turn it on, and let's see it work. And there we go. Press space to activate console. This is going to give you that little bootloader I was talking about. And it says boot into basic, cold, or warm. You can't do that from here. But what we're going to do is we're going to hit X to load CPM, and it's going to say boot CPM. We're going to say Y for yes, and there we are. We are in CPM. And so we got drives from A drive all the way up to the P drive. And so let's just go along. Let's see what's on each one. I'm going to admit I don't have a lot of nostalgia for CPM. I really did not work with it much way back in the day. But it is a lot like MS-DOS, which I did use. But like I said, CPM was a little bit after me. I got my first microcomputer right around... I got interested in computing in about 1979, I think, somewhere around there, and I learned BASIC and used some school computers. But my first computer, it's hard for me to remember back that far. It was a Texas Instruments TI-99-4A, but I want to say it was right around 1981 that I got it. Anyways, let's see what's on drive C. Nothing. Oh, we skipped drive B, didn't we? Basically, it's utility programs. Dpackage, DEPKG, allows you to basically uncompress some stuff that's on the drive, and I'll show you how to do that. You got Xmodem, download.com. You can essentially transfer, you can download stuff off of the internet, off various websites, and you can transfer it with a FTDI cable to the RC2014. All right, we know there's nothing on the C drive, so let's look at the D drive. E drive. Oh, here we go. So we got DBase 2, Infocom package. That's got to be, oh, there we go. Zork 1, 2, and 3. Microsoft Basic 80, Basic 85. Let's use dpackage to unpackage that. So if I'm not mistaken, we go B:DEPKG, and then we are going to uncompress it. So it's going to be in basic 85. Oh, wait a minute. I forgot the file extension. All right. B::DEPKG E::M basic 85.pkg. All right, let's see if this works. Yay, there we go. And on this version of BASIC, you can load and save to the CF card. So whatever work you do, you can save it and load it back up later. Okay, let's fire it up. So it should just be mbasic 85. Yep. mbasic 85. And there we go. Okay, so let's write our little program again. 10 for, whoops, x equals 0 to 10. And 30, next x. And let's go ahead and do it this way. 40 for x equals 10 to 0. Step minus 1. Alright, let's list it and let's run it. Ooh, we got bad stuff happening on line 20. Alright, let's try it again. 20. Alright, let's list it, see if line 20 looks good. Okay. And there we go. And I didn't have to do that weird thing where I hit the space bar for the for loop to execute. Okay, now let's save this. Save, we're going to call it hello.bas. And you can't see it because, once again, I can't figure out how to get my software to record two cameras at once. But my CF card light flashed. All right. To exit out, I think you do system. Yes. Okay. Now let's do directory. And there it is. Hello BAS is right there. And we can load it up again just by going in basic 85. All right, let's try to load hello.bas, and we list it, And there it is. Okay, it's all working. Let's take a look at a few things on the other drives. We're on the E drive. Let's go to the F drive, see what's there. G drive, wonder if we got games. And we do. Alright, so we could play Zork. Oh, Zork 1. What am I doing? Oh. So many days and nights spent playing Zork when I was a kid, and so many other text adventure games. You know, one thing that really surprises me, I teach kids to code, and I work primarily middle school students, 6th grade, 7th grade, 8th grade. And in today's world of, you know, high-speed 3D graphics and action games and everything else, I show them games like Zork, and they are absolutely enamored, and they want to know how to program them. In fact, you know, I think for every kid, not every kid, but I know when I got that Texas Instruments TI-99 4A in the Christmas of, I think, 1981, I'd already written out a whole notebook full of programs, and they were mostly text adventure game style programs. Now, like most kids, it was one big, gigantic, massive if statement, but that's okay. All right, so we're west of a house. You're standing in an open field west of a white house with a boarded front door. Of course, we're going to open the mailbox, and we're going to take the leaflet, and we're going to read the leaflet. All right, let's look. All right. Oops, went the wrong way. Oh, I'm in the, okay. This is dimly lit forest. You need a machete to go further west. Oh, there we go. There we are. Now we're north of the house. Back to the house. You're facing the north side of the White House. There's no door here, and all the windows are boarded up to the north. Narrow path through the trees. All right, we're behind the White House, so now we can open window, and we can enter. Anyways, I'm sure you don't want to sit here and watch me play Zork, so is it quit or exit? Yeah, it's quit. All right, so you have G, whoops. Let's try H. I doubt there's anything else on the rest of them. So anyways, I'm going to go ahead and end the video. We're getting a little long anyways. I've got a few other cards. I don't have them all soldered together. The one I'm most interested in is the Raspberry Pi terminal. The Raspberry Pi Zero terminal module, and the 512K ROM, 512K RAM module. But overall, this thing is an awesome little machine. It once again takes me back to the days of you know, the 1980s and my microcomputers back then. What was so great and so awesome about those machines is that they all had their own little personality. And you turned them on and they were ready to go. There was no configuring a development environment, no downloading libraries, no updates. You turned it on, it was ready to go. And I think for kids today learning to code, because that's one of the things I do, is I spend a lot of time teaching kids to code. It's that immediacy, that instant feedback that I think gets in the way. For a kid who's in, you know, 5th, 6th grade, trying to learn to code, downloading an environment, a language, getting it configured, and everything is, believe it or not, I know for us it's simple. It can be difficult for that kid. Anyways, enough of all that. It's a really super incredible machine. I can't wait to work with it. I've also got the ESP module to connect it to a Wi-Fi network, and that's one of the things I'm really most interested in, is getting this thing hooked up to the internet, dialing into BBSs, and maybe even running my own BBS. We'll see. Anyways, once again, I really appreciate it if you subscribe, hit like, comment down below. I'd really appreciate it. And if you got any questions, just let me know. Thanks a lot, everybody.